DC motors have wide spectrum of applications. They are used right from a small remote controlled car to large industry robots. So, it's important to know how the motor is performing over a period of time. The performance of motor under different load conditions are classified into three major characteristics. They are torque armature current characteristics, speed armature current characteristics, and speed torque characteristics. The first characteristics deals with the relationship between torque of the motor and the armature current. The second one deals with the speed of the motor and armature current. Third one deals with speed and torque of the motor. Now, to learn more about them, we need to classify motors into series and shunt motors. The type of motor depends on how the field windings are connected to armature windings. If they are connected in series, it is a series motor, and if they are connected in parallel, it is called a shunt motor. Now, let's look at three characteristics of DC shunt motor. We'll start with torque armature current characteristics. In shunt motor, the current flowing through the field winding is assumed to be constant as it is directly connected to the supply voltage. Because of that, the flux produced will be constant too. So, we can conclude that in a shunt motor, the magnetic flux will be approximately constant. Now, coming to the characteristics, we know that torque is given by this equation. Here, except T, Phi and Ia, all are constants. And in shunt motors, we are considering flux as constant too. So, from the equation, we can say that armature torque TA is directly proportional to armature current. When we plot the graph of this relation, we get a straight line passing through the origin. This means as the load on the motor increases, the armature current drawn from the power source increases. This current in turn increases the torque of the motor. We can also see the shaft torque versus armature current line. It is also a straight line and will be less than armature torque. We can infer from the graph that if the load is large, the torque required will be large and hence the current. Therefore, the shunt motor should not be started on a heavy load. This is about torque current characteristics. And the main inference is we should not start the shunt motor on a heavy load. Now, we'll move on to speed current characteristics. From our previous derivations, we have an equation for speed of the motor. Here, except N, the speed, EB, the back EMF, and Phi, the magnetic flux, all other terms are constant for a given motor. So, we can say that N is proportional to EB by Phi. The flux Phi will be a constant in a DC shunt motor. So, we have N, that is the speed of the motor, directly proportional to EB, which is the back EMF of the motor. The value of EB will be somewhat constant over a period of time. This means the speed will be constant in DC shunt motor. For the same reason, it is called a constant speed motor. We can see the constant speed line in the graph. However, in practical motors, there will be a slight drop in the back EMF over a period of time and hence the speed will drop gradually. As we see in the graph, it will be dropping. The speed drop will be around 5 to 15% over a period of time. As the speed remains constant, approximately, the loads can be connected or disconnected at any time and there is no risk of damaging the motor. Because of the constant speed, shunt motors are used in driving shafts, lathes and other machine tools. You might ask, we are talking about EB, but where is IA, the armature current? If you remember, EB is given as V minus IA RA. The only factor in this equation which changes is the armature current. So, we mean current when we talk about EB. So, this is about speed current characteristics, and the conclusion is the DC shunt motor is a constant speed motor. Now, let's move on to the last type, the speed torque characteristics. This characteristics of the motor is derived from other two characteristics. In the torque current characteristics, we saw that as the current increases, torque will increase, and in speed current characteristics, as the current increases, the speed will decrease. If we combine both of them, we can conclude as torque increases, the speed will decrease at different armature currents. As we see in the graph, the speed decreases for increasing torque. This characteristics helps us in choosing the best type of motor for a given load. That is it about the speed torque characteristics. It helps us in determining the type of motor for a particular load. These are the three characteristics of DC shunt motor. To sum up, we learnt about torque current characteristics, which says the shunt motor should not be started on a heavy load, and then the speed torque characteristics, which says that the shunt motor is a constant speed motor, and at the last, the torque speed characteristics, which helps us in choosing the type of motor. Understand the principles behind each characteristics and draw the graph accordingly. This question is asked frequently in the examination for 6 to 8 marks, and it is better if you understand the concept behind the characteristics. In the next video, we learn about the characteristics of series motor and how to represent them in the graph. See you there.